a strange world that we live in, and the future isn't what it used to be. We've always had such an infinite capacity for creation and compassion and joy, but also for rage and cruelty. You see, I think your life and everything is a non-linear system. We understand linear systems, cause and effect, positive correlation and negative correlation. The problem with a non-linear system is that the interactions quickly become too complex. No one remains one person. And what if a conversation could change the way that you think about yourself and the world? And what if everything that you held to be true was somehow, in some way, wrong? I'm Dr. Mark Halloran, and you're listening to Deep Trouble on 94.9 Main FM.
We're going to be looking at the skies, at the stars, at the heavens today. Our guest is Professor Ken Freeman, a noted astronomer. And Mark, you want to explain why Ken Freeman is famous in astronomy circles around the world?
Professor Ken Freeman is a Duffield Professor of Astronomy at the Australian National University in Canberra. His research interests are in the formation and dynamics of galaxies and globular clusters, and in particular, the problem of dark matter in galaxies. He was one of the first to point out in 1970 that spiral galaxies contain a large fraction of dark matter.
Explain what dark matter is, or why it became such an important issue in astronomy.
I'm not an astronomer or an astrophysicist, but dark matter is a form of matter thought to account for approximately 85% of matter in the universe, 85% of the total mass. Dark energy plus dark matter constitute 95% of total mass energy content.
The astronomers were doing their sums and they worked out that something wasn't adding up. They needed to factor in something to balance their equations. And they realised that a lot of the mass that was in the universe could not be seen. So they had to basically invent it. All scientists now accept that this dark matter does exist.
It's difficult to detect. It's called dark because it doesn't appear to interact with the electromagnetic field, which means it doesn't absorb, reflect, or emit electromagnetic radiation.
And Ken Freeman was one of the first people to postulate that dark matter existed.
A key point to it, though, is dark matter has not yet been observed directly.
All right, then. It hasn't been directly observed. Now, this brings up your famous phrase, Mark, that you've used a number of times in the second and third series, hypothetical construct.
Basically, a hypothetical construct is a construct that is not directly observable, but is validated by several independent observations which converge around that construct.
In a way, it's just a fancy term for a hypothesis, isn't it? Really?
Yeah, it's any construct which is useful. In the 1970s, at least, black holes would have been. You can't directly observe a black hole, but you could observe all of the physical, independent observations around it, the bending of light, things being drawn into this area of space and disappearing, that would validate the use of a construct like a black hole.
All right, so let's have a listen to this interview with Ken Freeman. There's a few surprises in it for you listeners, because Professor Ken Freeman reveals that he's quite a complex character, and you'll be fascinated with the direction this particular interview heads. So, Mark, what about we hear the interview?
Yeah, sure. So I began the interview by asking him if dark matter was, in essence, a hypothetical construct.
No, look, the construct itself is pretty real. It's pretty easy to detect. And there's not much doubt that it's there, but it's just we don't know what it is. I mean, it's got to be made of something, but at the moment we really don't know what it is, and we're probably, knowledge is not about that. It's not going forwards very fast. There's a lot of work being put into trying to work out what it is. Some of that's astronomical work and some of it's more in the physics labs, because this stuff is all around us. I mean, your room is now full of it. My room's full of it. and people are trying to detect in physics laboratories various kinds of possibilities. So far, none of them have panned out. I mean, one of these days, one of them will, I hope. People are trying all sorts of particles in the subatomic particle world, but so far, people have been doing this for a long, long time. Some experiments going on down in mines where people are trying to detect various kinds of particles. Some of these particles are so weakly interacting that they can pass right through the Earth without basically interacting with anything. Some of the particles you're actually better off down in the mine where there's not much other particle activity going on, and you pick up things that are actually coming right through the Earth. So a lot of this sort of stuff going on, but as I say, so far, none of this has panned out yet.
It's occurring at the quantum level.
Yeah, right down at the elementary particle level. There's a whole zoo of possibilities there, and some of the ones that were easier to work on are being worked on, have been worked on for decades actually, but not with success yet.
Do we know anything about the qualities of dark matter?
Not much. There's a working hypothesis that it's cold, and what cold means is the particles are moving slowly compared with the speed of light. And that's partly a theoretical construct because there's such a lot of this stuff is part of the basic structure of galaxies. So as the universe evolved, you needed this stuff to settle down into lumps. And then those were sort of backbones of galaxies. That part we can see, that backbone is there. But to condense into these sort of lumps, the stuff's got to be moving fairly slowly. If it's moving very fast, it's just got too much energy to really settle down and condense. So that's the working hypothesis. This stuff is cold, and it's just called cold dark matter. Now, there's a possibility that that's not quite right. The stuff could be what's called warm dark matter, where the stuff is moving around rather faster. It can't be going very fast, otherwise it couldn't condense. But that's about the level of knowledge of its particular properties. We know it's gravitating, because that's how we detect it. And that's actually much more straightforward than you might think. I mean, to detect gravitational fields in astronomy is actually relatively easy. You just look and see how things are moving and then work that backwards. And in some cases, working it backwards is a very simple process. You start with how things are moving inside galaxies. From that, you can infer what the gravitational field is. In some cases, the galaxies are just simply rotating, and everything's just going round and round in circles. And that's a very easy situation in which to measure gravity. It's almost trivial. It's very hard to see what could be wrong with that sort of argument.
I don't understand any of this very well, but from a philosophical perspective, whether it was validated like hypothetical constructs, well, I don't know what the status is now. I think that they've taken images of event horizons of black holes, but black holes were once considered to be hypothetical because they were only validated by several independent observations around them, such as the bending of light and things like that. So I was wondering if dark matter was in the same category.
No. In some ways, it's less dramatic than black holes. I mean, dark matter and black holes aren't the same thing. Black holes are just when you get a certain amount of matter, and that can just be perfectly normal, ordinary matter. It could be stars or it could be just the same material.
I didn't mean that in that sense. I just meant in the sense of being a hypothetical construct, in that they're not observable in themselves.
They're not directly observable. Yeah, that's probably a fair view. Black holes, I think, are basically now past the hypothetical construct thing. I mean, I think they're as real as anything in astronomy. I mean, there's just so much evidence for them. You know, this last thing with the galactic black hole, I mean, that was brilliant. That's a fantastic observation. Even before that, there were a whole bunch of things where there was pretty much no doubt that they were black holes. And the thing that was actually imaged by this Event Horizon Telescope, I mean, the evidence that was a black hole has been for years much incontrovertible. So, I mean, it was certainly the case in the beginning with the black holes that they were a construct, but the evidence is now just so strong you'd be very hard-pressed to convince anybody that they weren't real.
Is it directly observable, or is it still the case that it's the secondary observations of the effects?
Look, most of it is the secondary observations. It's just the fact that you've got this very, very intense source of gravity, and it has all sorts of consequences. Sometimes it's stuff that gets trapped not in it but around it, and that stuff, when it falls into the black hole, loses so much energy. That energy's got to go somewhere, and mostly comes out in various kinds of unusual radiation. And there's so much of that, and there's so many examples of that around. And the other thing is with the big black holes, like the one that was imaged with the Event Horizon Telescope, they have such a gravitating effect on their environment that you can see it directly in what the other stars nearby are doing. And there's one amazing example in our own galaxy where you can actually watch individual stars buzzing around the central black hole. Well, you can't see the black hole directly in optical light, but the gravity is so intense there that you have stars buzzing around the black hole. Mostly in astronomy, things take literally hundreds of millions of years to do anything. The scales are so big. But here, with this intense gravitational field, the stars are going right around the black hole in something of the order of 20 years. And this is absolutely amazing because, I mean, on a galactic scale, you're seeing things happening on human timescales, and there's absolutely no other way that could be the case other than this thing being a black hole. It's just far too dense to be anything else. So, yeah, I mean, in some ways it is still a hypothetical construct, but the observational evidence for it is just so strong that it's really hard to get away from.
After I read your book, I kind of think, and I'd had the same conversation with Chris Mulheron, that the conversations between yourself, you're a person of faith, a Christian,
Yes.
and maybe the arguments with people, the new atheists, Richard Dawkins, were arguments at a cross purpose because God isn't a scientific construct or a hypothetical construct.
No, absolutely. That's right. That's right, exactly. Yeah, in a way, for the scientist Christian, it is a sort of a split, because you have your life of faith, which is absolutely built on faith. It's built on God's revelation to us, and then on the other hand, you're working away. In my case, on the universe. Where if you're a biologist, you'd be working on biological things, and there you work as a scientist, and everything has to be experimentally verifiable, and any experiments you do must be repeatable. I mean, that's one of the things of the scientific method. If you do some experiment that shows something, that has to be documented well enough so somebody else can do it with a reasonable chance of success. And, of course, you can't do experiments on God. That's just absolutely not part of the equation of faith. And so you really have these sort of almost two ways of doing your business. And, it's sort of interesting, but it is different. But I certainly disagree very strongly with some of the people who take the view that we occasionally get letters to the paper here in Canberra saying that I would become a Christian if you could show me some experimental evidence that could be repeated for the existence of God. Well, that's not going to happen. People have been thinking about this for millennia, and it's pretty clear that just the nature of God, I think, is just an experimentally unverifiable thing, and almost by definition. So there's certainly a bunch of people out there who don't buy that concept at all. I mean, they're children of a scientific age, and they think everything has to be scientifically or experimentally verifiable, and I don't think that's a realistic concept.
You're listening to the Deep Trouble podcast. Dr. Mark Halloran in conversation with Professor Ken Freeman, Australian astronomer and astrophysicist.
In terms of your book, God and Galileo, you talk about the book of nature and the book of scripture, or
Yes.
Galileo does. And so essentially they're separate systems. From a Christian's perspective, they'd be interdependent but almost mutually exclusive.
Yeah, almost, but I mean, they are interdependent because we see God as creator. But when we're exploring the nature of the creation, I mean, that is something we can approach experimentally. When God did something and produced the universe, and our job as scientists is to try and work out what it was that God did in that process. I don't think we're going to see God directly or verify the existence or otherwise of God, but what we are able experimentally to explore the sort of consequences of his creation, whether we're biologists or whether we're astronomers or whatever we are.
Well, to some extent you talk about the biologist looking through the microscope or yourself looking through the telescope, seeing things that validate their belief in God, though. And I wonder if it's a problem to have a non-scientific concept or construct at the top of a scientific system.
Well, if it is a problem, I think it's one we've got to live with. I don't really see a way out of it. I mean, I don't see God being recast into a scientific concept. I mean, we may be able to, in the fullness of time, be able to figure out what God did. But to actually verify the existence of God or the nature of God, I just don't see how we can do it.
I don't know how you would like to classify yourself, but it would seem to me that you would be, from an outsider's perspective, classified as a theistic evolutionist. So essentially there's certain beliefs that go along with that, such as a belief in the prevailing cosmological model with the universe being about 13.8 billion years old, and then a fine-tuned universe, but also there being evolution and natural selection, and no special supernatural intervention is involved once evolution got underway.
Yeah, and look, that's a sort of a thing that people argue about. I mean, some of my colleagues would take that, who are Christians, would take that view that, they sort of paraphrase it as God sort of lit the blue touch paper and stood back and didn't intervene from then on. Yes. I wouldn't personally take that view. My view is that God does intervene. I mean, the whole point of prayer is that God intervenes, and we've certainly got plenty of recorded miracles where God has intervened in the system. So I'm not really a believer in a completely hands-off God, because I just don't think it's the way that things are. But certainly some of my colleagues would take that view, particularly in terms of cosmological things, that it is the process started and then it just ran. That may be, but I think at the level of human interactions, I think God does intervene. And I mean, people pray for rain, and I think it's a perfectly valid thing to do. And we're asking for intervention, and I think we sometimes get it. That gets us into all sorts of other issues about why God intervenes sometimes and not other times, and don't have much insight into that. So.
We'd touched base on this in relation to our communication via email before this, but you wouldn't be believing in interventionist God in relation to your work, because you would probably be approaching your work from a perspective of methodological naturalism, which is that,
yes, that's right.
That when I'm doing an experiment, I can't expect that God would intervene, although perhaps the strangeness of the quantum level for quantum physicists might mean that they think that
yeah.
God intervenes sometimes.
Yeah, that's sort of beyond my pay grade, that one.
Yes.
But yeah, no, I'm particularly sort of looking at the human scale for intervention, because I think that's where we see it. We had the big intervention. I think we say something about that in the book, that the incarnation was a massive sort of intervention that wouldn't be part of the normal run of things in the universe.
You're talking about Jesus Christ, because
yes.
That is an exception there in terms of Christian belief, because that means that God enters into the material world, so the domain of physical science.
Yeah, so that's a big part of our belief, and I think Christians see that as a major part of Revelation. It's something I certainly have no difficulty with. I have no difficulty in believing it. Yeah, so
I wonder if there is your work, your empirical, your scientific life, and then there is your faith and the idea of grace, which forms part of your emotional life. Mm-hmm. That they're separate things, essentially.
Yeah, but it's possibly more than just your emotional life. I mean, it's a big part of human reality, as I see it. And stuff that I believe and the stuff that I don't think is experimentally verifiable. I mean, I wouldn't want to try and experimentally verify the power of prayer, for example. We're told that God would frown upon that, and I think that would be quite a reasonable thing. I mean, when going to the scientific side of it, we're sort of locked into the scientific method. It's a strange sort of thing. I mean, when you're presenting your science, you present it in a very often rather mathematical and certainly logical and reproducible way. You make some discovery. You describe the experiment and you make it detailed enough so anybody else could do the same thing if they want to check it.
One of the things that interests me is the cosmological models, which are mathematical models with assumptions that are built into them, which are decided upon. Mm-hmm. And if you take the beginning of the universe is not a directly observable event, but it could be observed by things that are continuing to happen now.
Yes.
Like the light from a star that reaches Earth might be from a star that died, billions of years ago, essentially, but the light's still reaching us. But I wonder whether there is an issue in terms of extrapolation, whether extrapolation across space and extrapolation backwards through time, that you have an issue with error increasing and that affects your ability to truly know.
I mean, for example, most of the stuff I do doesn't involve relativity. I mean, there's a few things that do, and that's particularly to do with things like deflection of light, which is a rather sort of delicate effect, how the way that gravity can actually act as a lens. But mostly I work in what you'd call a Newtonian domain. I'm interested in the dynamics of individual galaxies. The dark matter stuff I do, that's all on scales where relativity would hardly contribute anything. I mean, relativity is correct, of course, at all these levels, but its effect compared with the classical Newtonian approaches is really tiny. So basically all of that stuff is done in a non-relativistic framework. And you go to relativity when you have to do it, when you have very intense gravitational fields, for example, or things where gravity is just a tiny effect, but because it's multiplied by huge distances, like the deflection of light. I mean, a star deflects the light from another star, and that can be quite a visible effect over very large scales. But in terms of the way stars move, for the most part, relativity is not particularly important on galactic scales. It becomes much more important on bigger scales. Yeah, so you use what theory you need when you're making cosmological models. Relativity, of course, does come into it, and it's all part of it.
One of the ideas that you have is in terms of a finely tuned universe. And, we talk about gravity in terms of those things and other things being creating, particularly this planet, the perfect conditions for life. Mm-hmm. But I wonder whether that's making meaning from the observations, like creating extra meaning.
Yeah, this is not something I've worked on myself, and my colleagues have. But it is true that if the parameters of the universe were significantly different, life of the kind that we know it probably wouldn't exist.
Right.
You need time for elements to form in the stars and basically provide the kind of chemical background that we need. And to get that time, you need some of the constants of the universe to be pretty much what they are, particularly the gravitational constant, the rate at which the universe is expanding. They're two different things. They can't be terribly different, or the universe would be too different. I mean, it'd still be a universe of some sort, but it wouldn't be the sort that the kind of life that we know could exist. But I mean, it may be to be quite a different kind of life would exist in quite different circumstances. But anyway, the way the universe is matches the kind of life that has developed in it. But is that cause or is that effect?
Or could just some other version just have been another version, essentially?
Well, it could have been, but the consequences may be somewhat different. But that's okay. Right. So the consequence is different,
You've said that the concept of a multiverse is an unscientific construct, because I suppose sometimes the multiverse is, well, I don't know, is brought forward to explain away finely tuned universes.
Well, it's partly that. I mean, our view, and I think we say a bit on this in the book, is that the multiverse concept is sort of there to step around the idea that there's some purpose in the universe. I mean, I think as a Christian scientist, I would say that there is some purpose in the universe, and that purpose is very much God-focused. And one way, the universe was basically created as a place where you could have the kind of life we have. On the other hand, a lot of people don't like that idea. The idea of purpose within science is, for some people, is really not acceptable.
It's sort of intelligent design.
Yeah.
Purpose is intelligent design by proxy, essentially.
Yeah. So, if you don't want to accept that, well, then one way out would be have a very large set of universes, and that one of them would be suitable for this kind of life, and you have no way of knowing what the other ones are. I have colleagues who work in this sort of area, and they're, for the most part, very caustic about the whole concept because of its unscientific, unprovable nature, that it's almost pseudoscience.
Well, you said that you need an atom smasher this as large as the Milky Way to provide the gateway to potentially...
well, that's right. I mean, or probably even worse, Yeah, so that's not one that I'm too keen on myself.
Well, I guess from the perspective of, say, the atheists, an atheist might just say, well, the reason that we see purpose is because we just happen to be here to see purpose.
Yeah.
It's one of those unsolvable things that goes around in circles.
Yeah, but to say that, you have to turn your back on revelation, which a lot of people are quite happy to do. I'm personally not. I take that very seriously. Yeah, so...
But, I mean, that was my point before, and I may not have really got to the heart of it, but to some extent it's about, emotional and personal relationships. So it's not as though you're looking at your faith and looking at the Gospels and looking at it cold-eyed. You have an emotional connection to the story. Yeah,
for me the sort of sequence would be that, do you believe in God? And if you do believe in God, then you would look to see what God has shown us about himself. And once you get into that, you're then in the whole revelation cycle. So it's really, for me, it's really the basic thing is the belief in God. And once you've got that, then I think, certainly how it is for me, then the rest of it would follow. Now, if you are convinced for whatever reason that God doesn't exist, then you would regard the whole revelation package as just airy-fairy fantasy stuff, but I'm not in that company personally.
You're listening to the Deep Trouble podcast. Dr. Mark Halloran in conversation with Professor Ken Freeman, Australian astronomer and astrophysicist.
And in terms of revelation within other religious systems, what do you think of that?
Well, yeah, I take it pretty seriously, and I mean, it's something I'm very interested in. I haven't really studied it professionally or anything, but I would certainly not say that the Christian revelation is the only one. Now, just exactly why there are these various sets of revelation, I can't tell you. But I certainly take other people's revelation, the existence of that, as being pretty serious. I mean, these things in many cases have survived for millennia, and there's certainly some robustness in them.
I mean, every human civilization has found something divine. I know I talked about this with Reverend Tim Costello.
Oh, yes.
And so that commonality across time and across the evolution of people and different cultures, there is some system of thought that says, well, there's a reaching for something.
Yeah, well, I mean, whether it's a reaching for something or something being almost put in your face, I'm just not sure. Whether it is something that we're reaching for or if it's something that's actually offered to us.
What does faith bring to your life that you think that other people that don't have faith or a revelation lack?
Well, I would say probably the main thing is purpose. My life is sort of there for God to use. I think that's a very important component of my own life. If I didn't have that, I mean, it would be a different story. My life would be sort of wrapped up entirely in science, domestic things. It would be a life, but I like the one I've got better. Yes, I think it's the purpose aspect. I think is the important bit.
Yeah, I suppose the emotional thing in terms of like a relationship, because a lot of people talk about a personal relationship with God, which I'm quite interested in. Yeah, so one of my favourite masses was the Easter Mass. And during the crucifixion, I liked the Mass because it was dramatic, but it was also very emotional. And so when Jesus says to God, who's his Father, it's a complicated relationship because he's also himself. He says in the Aramaic, Eli, Eli, lama sabachthani, which means my Father, or my God, why have you abandoned me? I think a lot of people would connect to the emotion of that, of the feeling of being abandoned. It's not just the story that's relayed, that people have an emotional relationship to the stories, Do you understand what I mean?
Absolutely, I do indeed.
And it's telling something about human experience as well.
Yeah, but I mean, I think as you were alluding, it's a terribly complicated thing. I mean, it's something I don't want to get into because I'm not competent to do it, but the whole nature of the Trinity, the 3 in 1 and 1 in 3, and the whole process of the crucifixion and the resurrection, it's immensely complex. It's something I'm actually doing a bit of reading now to try and just inform myself a little bit better about what thinking is. But it's a fantastically complex thing, and the whole picture of what happened around Easter time is so bound up with the nature of the Trinity that there's an enormous amount, I think, there to be understood if one's capable of understanding it. Does that make any sense?
Yeah, because of course what you're talking about is 3 distinct entities which are also one.
Exactly.
And so that's not something that is within most people's experience.
No, that's exactly right. Yeah, so I really haven't got my head around that properly at all at this point.
If you read the Torah, if you read the Gospels, you really are reading ideas around what it is to be human.
Yeah.
In terms of the negative and the positive.
Yes, quite.
Some of the difficult questions, and I talked to Chris about this as well, but the idea that God is retreating in the face of science.
Oh, goodness, I don't see that at all. That's just an entirely earthly concept, I think.
The example that I talked about with Chris, and we talked about it to some extent, but it was in relation to, so I said, well, if you're a Christian, even 200-300 years ago, then the creation story might have been a reasonably acceptable account of how human beings came to be, so a world that's somewhere between 6 to 10,000 year old based upon the genealogies put forward in the books in the Old Testament, not a 13.8 billion year old one, and that seemed like a seeding of ground to science as it's sort of eroding away at those things. You either become a creationist and deny the science, which is not really possible to do anymore, or you have to integrate it in somehow, and so it becomes a new theology.
Yeah, that's right. I mean, the creation story is certainly one of the issues there, but, there are quite a few others where things were ascribed to God because they were just outside people's comprehension, and then gradually we learned, well, these are not kind of divine things. I mean, for example, just one a few years ago, David Block, my co-author, and I went to Norway, and we went to see the aurora. And we heard some of the old myths about the aurora, how there were various divine things going on up there. And of course, within a few hundred years, we sort of understand the aurora much better. It's part of the processes that go on in the Earth with the Earth's magnetic field. And so that's one thing where something that was ascribed to God is now no longer ascribed to God. And in that sense, I really don't see that stuff as a retreat by God. I mean, it's just that we found out a bit more, and there's going to be lots more things that we find out, I hope. I mean, I imagine we look back 100 years at what science looked like then and how it compares to what we've got now. So we only have to look forward another 100 years and imagine how our science is going to look to people in, say, 2120, and it's going to look pretty basic. Unless something really catastrophic happens to the world. I mean, if the things progress as they're likely to progress, I mean, science will be way advanced over what we've got now. And what we're doing now would sort of look like the science of the early 20th century looks to us now, I mean, there's some very important things were done in that time, and they're recognised, and hopefully some of the things we've done recently will be important enough to survive, but science will move on enormously. I mean, in 1910, we didn't even know what galaxies were. And we didn't know whether they were big things like the Milky Way or whether they were just little things where individual stars were forming. And really, people didn't know that. And that didn't get sorted out until around 1920. It's only 100 years ago.
You're listening to the Deep Trouble podcast. Dr. Mark Halloran in conversation with Professor Ken Freeman, Australian astronomer and astrophysicist.
Look, there's something that might be a little bit peripheral to what we're talking about, but I think not completely. And it's the thing about, I would have liked to have something in the book about it, but it just didn't really quite fit. And that is the role of intuition in science.
Yes.
When I was saying that with the scientific method, when we present science, there's a particular recipe that we have to use. So
yes.
We've got to describe things in a lot of detail, so there's absolutely no question about what we're trying to say. And also that if it's an experimental thing, that somebody else could do the same experiment.
Reproducibility.
As long as they're competent to do it. But that's not the way we actually do the science, or certainly not the way most of us do the science. I mean, if I'm starting to think about some scientific project, I don't sit down and analyse it from beginning to end. And I use my gut feeling a lot. There's a bit of a literature on this. Unfortunately, I can't quite remember the names of the people, and it's the sort of thing that people say there is how important this intuition is, and if people didn't use that, scientific progress would sort of grind to a halt. So you follow your intuition into something, and you do experiments, and some of them succeed and some of them fail, but you kind of all the time following your gut instinct. You do various computations and you do all sorts of things, but it's not at the level of what you would then in the end present. So you sort of stagger in this kind of intuitive way from a concept to what's basically a discovery, and then you present it, but you don't present it in that sort of way at all. You present it as a well thought out, reproducible result of experiment.
You're putting the human part of it in there, that you'd have to have some sort of inspiration. But I would say that because of your experience and your extensive knowledge in your field, that even if you're having that inspiration, that it's, I don't like the term, but subconsciously you're working on that, and that comes up.
Yeah, well, absolutely. I think the role of the subconscious is very significant here. Einstein wrote about this too, saying that if people were I can't exactly remember what the words were, but the gist of it was that people were not able to use their intuition. Science would basically grind to a halt. I'm really paraphrasing this, but that was the sort of idea that this is not something to be decried. It's an essential part of pretty advanced science. Of course, you need the basic knowledge, you need the basic technical skills to do whatever it is you're going to do. But I think once in my life I have actually started a concept from the beginning, and the concept came to me because of some logic that I'd used. And it was almost, I actually did the project almost in the order that I would write it up. But this is almost a one-time thing in a lifetime. Most of the things that I do aren't done that way at all. And things come to you absolutely out of nowhere. And this is something that's part of that sort of literature about the role of intuition. You're puzzling away on some project, and suddenly out of the blue comes something that you hadn't thought of at all. And where that comes from, whether it's something that's buried deep in your subconscious, whether it's sort of a divine hint or just what, I don't know, and we probably never will know, but it's quite an important element of the way we actually do our business.
Yeah, I seem to remember about Nobel Prize winners dreaming about things, solving chemical structures, right, and dreaming of snakes that eat their own... I can't remember the exact story, but it seems like your mind continues to work on it after it's stopped.
Absolutely. You go to bed with some problem and you wake up and suddenly you know what the answer is, How these things work, I really have no idea, but they're very interesting, and they're a bit of a reflection on the scientific method. The scientific method is really something that we're sort of locked into because it's the way that science does its business. It's a sort of a veneer. Nothing wrong with that, but it's just the way it is, but it is a bit of a veneer.
To look more logical and pragmatic than it actually is, in its initial conception stage.
Yeah, exactly.
I did want to talk to you about Galileo's letter to the Grand Duchess of Christina of Tuscany, because I feel like that's the heart of your book. And Galileo argues for the divide between the book of nature, science, and the book of scripture. And like Augustine, he cautions there should be careful interpretation, and so they use the example of Job 38:4 and foundations of the earth. And what I wondered was why Galileo or Augustine should be thought of as knowing really any more about what should be considered to be, when it comes down to it, the heart of it, allegorical and non-allegorical within a book, within the Bible.
Yeah. I've got enormous respect for the early church fathers. I mean, they had the stories of the early Christian times delivered to them, and they had to kind of make sense out of it. And Augustine, I think, is absolutely fantastic. The things that he thought of in early times. So he's somebody I would take very seriously. Galileo was in a funny position because he was really in danger of his own life because he was so obstreperous. And he had these understandings with the church about what it was reasonable to do and what it was unreasonable. If he'd stuck to those, his life would have been much easier, the church's life would have been much easier, and I think they could have got through this period with much less disruption. But anyway, because Galileo was Galileo, he was pretty disruptive. As a result of this, he got himself into all sorts of strife, not just with the church hierarchy, but also with people who were a bit lower down, church people who were a bit lower down. And I think his letter to the Duchess was it was partly to protect his own skin. He was trying to get some of these things off his chest, how unreasonable he thought the church hierarchy were being in their views about the interpretation of Scripture. And that's really mainly what the letter's about. It's very, you would have seen it's pretty repetitive.
They saw it as defending their ground, didn't they? I mean, they were happy, as far as I can tell, with the Copernican theory as a theory,
yes,
but
exactly.
They saw it as a threat to their own authority.
Yep. You're absolutely right.
Yeah.
That's exactly what it was. And it wasn't really a battle between science and religion. It was a battle between science and the power of the church. I don't think it had too much to do with what the church was believing, but they really did treasure their power to be the sort of source of knowledge for the people. And they were very defensive about translations of the Bible. And I think they could see perfectly well what was coming if sort of analytic science got too much power. And so they were perfectly happy to use Copernicus's theory for structuring their calendar. But they just didn't want to have it as more than a theory, as actual fact out there. And I don't know whether Galileo got this or whether he was really looking too much at his own situation of his personal science not being accepted. But I don't think it was for scientific reasons. It was for these power reasons. Yeah, I mean, that went on then for quite a while. But I think we'll probably say this in the book somewhere, that if Galileo had just played a little bit cooler, and hadn't pushed them quite so hard, an awful lot of this tension that arose in Galilean and post-Galilean times too, I mean, this went on. I think a lot of that could have been, at least at some level, could have been sidestepped. And the whole tension between science and religion might have been put off. I mean, it came back in a big way in the 19th century. That might have happened anyway, but I think the whole Galilean episode could have easily been avoided if Galileo had been a little bit more compromising, and it wouldn't have cost him anything. I mean, it didn't cost Copernicus anything. The Copernican view worked reasonably well. I mean, it had predictive power. That's why the church was using it for their calendar, because it worked.
Yeah. But that seems like from their perspective it would have undermined the idea of the way that the universe is structured, to move it from the Aristotle idea to the Copernican.
Yeah, no, that's absolutely right.
So they saw it as a threat in that respect, that it undermined Scripture, and that was essentially the heart.
Yeah, but I think the thing it was undermining was the church's role as the sort of fount of all knowledge. They seemed to be able to cope with using Copernican theory as something for their own use.
It wouldn't be widely distributed amongst people, and so that seems like the threat, that if people get a different idea and then they go, well, we're not going to believe what they say, then that's the threat.
Yeah, I agree. Yeah, so.
And also, I was interested in this, and I feel like this is an article of faith as well, because I haven't really found anyone that could really explain this to me, and we might be just talking about this as a talking point, essentially. Yeah. But the decision, whether we're talking about early church fathers, and was it Augustine warning about, conflating scientific ideas with scriptural ideas and the danger of that. But the idea of what is allegorical in the Bible and what is like talking about an event, a factual event. If we say the creation story is allegorical or Jonah and the whale is allegorical, then we could also say that the resurrection is allegorical. That makes sense. And so it has to be an article of faith, that there's a distinction between these things.
I think perhaps the difference between the sort of creation story and the resurrection story is that the resurrection story is much closer to the present time, and a lot more people saw it and it was documented. Whereas I think with the creation story, it's a sort of difficult thing. I have a colleague here who's very interested in this creation story thing, and he's a clergyman himself, but he has friends, young Earth creationists, and he's trying to persuade them of the error of their ways. And he's been reading a lot of stuff about what's people's views, Old Testament scholarship on the creation. And he's sort of reading things that regard the creation story as sort of cultural things. It was written to the people of that time. Now, it's a pretty good story, and it's got a lot of elements, that are pretty close to being truth, physical truths, if you interpret them with a bit of latitude. But I think they are things that were written for their time. I think Augustine sort of looked at the things perhaps in a somewhat similar way. He had this thing that I think we cite in the book, that if there's something in the Bible that disagrees with your immediate experience, then you better try and reinterpret what you're reading in the Bible. And I think Galileo used that as part of his gripe against the church.
Yeah, so I suppose what we've been talking about is faith.
Yeah.
Across all levels of life.
Yeah, no, I think that's right. I think situations are amenable to faith that are just not amenable to the scientific method. I mean, that would be my take on it.
I guess my takeaway from reading your book was, both for you and your co-author, David Block, was that the richness that faith gives you in your life.
Yeah, no, certainly no doubt about that. Yeah. There's a surprising number of Christian scholars out there. Yeah,
well, Chris Mulheron has sent me a book that he's written with all of the very, very prominent scientists such as yourself,
There's a whole bunch of them who don't sort of really come out. I mean, they're there, and you just sort of run into them, often in unexpected situations. And there's people I've worked with really almost all my life who are very serious Christians, but it never comes up at all. No, that's fine. That's their choice. But there's many more of them than I thought.
Thank you.
Okay.
Yeah.
I hope that's been some use.
And so you've just heard the interview that Dr. Mark Halloran did with Professor Ken Freeman. And What is of particular interest, Mark, is Ken Freeman's ability to balance a really hard-nosed scientific approach to his chosen field, astronomy, and his devout religious belief.
Chris Mulheron also made this point around methodological naturalism, that when you're conducting an experiment or a scientific observation, you don't believe in an interventionist God. You don't believe that God's an active agent working in the universe at that point. It's a very interesting distinction. I think what's clear in the interview, or the way that I phrase it, or I think I provide a statement of the idea, is that God and religious faith is a metaphysical system which is not part of the natural universe, and therefore independent, and therefore not a question for empiricism. I think that seems like the reasonable way that you would approach this if you took it as an article of faith.
Yes.
If you take methodological naturalism, that sort of sounds a bit more like Descartes, who's got the mechanical universe where God kind of put everything in order and then stands back and isn't interfering anymore. It's just wound up and ticking over, if that makes sense.
But I'll tell you what this leads into.
What's that?
Faith.
Yes.
And belief. And somebody who knows a bit about psychology, could you explain that?
Well, I can only talk about it in relation to my recent readings about authoritarianism.
Yes.
Well, they say that ideology gives you the ability to ignore complexity. But in fact, when they've looked at people who have a tendency towards authoritarianism, they are actually quite good at complexity. They just choose to ignore it. If you think of religious faith simply as an ideology, what does an ideology give you? It gives you a sense of group. It gives you a sense of purpose and meaning in life. So it gives you a narrative that is larger than yourself. It's sort of superordinate to yourself. We talk about that with Rachel Menzies, and we'll talk about it again with another Halloran, with terror management theory, that the idea of having an ideology, because we're mortal and we live with death anxiety and that we'll die, that we need to believe in something that's beyond ourselves, whether that's nationalism or whether that's Catholicism, or it might be feminism. So it gives us a sense of belonging to a group. So there are other people who believe the same things that we believe. And then the second part is that it gives us a great sense of meaning in our personal lives. Mm-hmm. And a sense of maybe continuing on after us as well. That would be the simplified version of how I would think about ideology. I mean, I probably would need to think about it a lot longer.
Right. It seems to me that the world is a scary place, and we do need these structures to make sense of it. They're like a security blanket. And I'm thinking that if I was an astronomer gazing into the night sky every night and being continually reminded of the vast scale of the universe, I think I'd be feeling quite insignificant, and I'd be looking for something to hold on to.
Yeah, what do you do with infinity? I mean, what do you do with something that's sublime and the immense complexity of it all? I think if you took away the stories themselves, which we talked about early on, we talked about different faith traditions, whether it's Hinduism and Islam, and Ken had a very interesting take that he thought that they all touched upon some sort of truth. So let's say for us, if we took away the stories themselves, the Judaic-Christian story or the Islamic story, and you said to yourself, like, there is either a beginning with the Big Bang and no meaning beyond that, or there may be some absolutely unknowable intelligence that is involved in some way and created it. Would that be so hard to believe? I mean, it certainly wouldn't be provable necessarily, but it wouldn't necessarily be difficult to believe, I don't think. This came up with Tim Costello. Every civilization has looked for something beyond metaphysically to explain the creation of the world and the universe and to give meaning to their lives. So perhaps that reaching out is reaching out to something.
I felt that this book, God and Galileo, what a 400-year-old letter teaches us about faith and science, is not aimed at atheists. It's aimed at other devoutly religious people. It's trying to reach them and telling them, don't be so literal in your interpretation of the Bible. It's playing to that market.
The biggest problem that they have are the young Earth creationists.
Yes.
It's a part of the Seventh-day Adventists and Seventh-day Adventist Reformed Church. So that's problematic. So sort of evolution deniers, young creationists, I think you're right. They're trying to say what you're doing is actually undermining our faith because we feel as though it's easily demonstrated these ideas are wrong.
You know, that's what Galileo was implying in his letter to the Duchess of Tuscany, that those critics of his who were challenging his astronomical discoveries were bringing, or at risk of bringing, the church into disrepute because their literal interpretation of the Bible was so easily refuted.
Yeah, so he was ahead of his time in that respect, in that he could foresee that eventually, as science was progressing, even then, that there would be stories and narratives in the Old and New Testament that just wouldn't hold.
And, you know, in a way, I do see this parallel between Professor Ken Freeman and Galileo. Now that I think about it, the reason why he's so interested in this subject, that he wrote a book about it in collaboration, because within the world that he inhabits of people of faith, that his desire to separate out science from faith, he's in the same boat as Galileo. And here's another parallel. Galileo advocated harmony between science and scripture and refrainment from persecution of scientists by the church. God and Galileo exposes a new form of persecution, that towards scientists who proclaim the grace of God, whose careers and ability to be published in peer-reviewed journals may be jeopardised because of their openness towards talking about their faith.
Yeah, well, I think his point is that there's a part in the book where a colleague says to him when he's being interviewed, he says, "Can you stop talking about God? So we're happy for you to represent whatever the institute was, but just please stop talking about God." And so I think underneath that, there's almost an issue of freedom as well. Like, I know people who are scientists and their faith is Hinduism. To some extent, other scientists who don't share those religious beliefs need to step away from that, and that people should have their own freedom to choose and talk about their religious faith as well.
One last thing. In Galileo's letter to the Grand Duchess, he says this: before a physical proposition is condemned, it must be shown to be not rigorously demonstrated. And this is to be done not by those who hold a proposition to be true, but by those who judge it to be false. This seems very reasonable and natural, for those who believe an argument to be false may much more easily find the fallacies in it than men who consider it to be true and conclusive. To me, that is a statement about the nature of the scientific method. Do you see my point? Galileo is stating there what we've come to know as the strength of the scientific method. That is, you must approach a hypothesis as if it is false.
Yeah, you shouldn't be trying to prove your hypothesis. You should be trying to disprove it.
Absolutely.
And in the act of disproving it, you strengthen it.
Okay, Mark. So that's it for this season, the third season.
Yeah.
You'll be able to get a chance to listen again to the third season, and we've put it up on the Deep Trouble Mixcloud page.
Yeah, thank you very much to all the listeners for their loyalty, and all of the interviews that we've done to date can be found on the Trouble Mag website under Deep Trouble.
Deep Trouble is produced by Steve Charman in the studios of Main FM, Castle, Maine. Deep Trouble is produced by Steve Charman in the studios of Main FM, Castle, Maine.
The Deep Trouble podcast is presented by Trouble Magazine at troublemag.com. Thanks for listening.